From virtual patients that fuse decades of healthcare data, to language models that can plan actions safely in the physical world, to multimodal systems judged on how well they build and repair real websites, today's papers reveal how fast AI is expanding beyond text. We'll explore what these models learn, where they excel, and where they still fail in surprising ways. Stay with us as we connect healthcare, safety, and web coding into one compelling look at the next frontier of AI. Let's explore the first paper, a multimodal and temporal foundation model for virtual patient representations at healthcare system scale. Apollo is a multimodal temporal foundation model trained on MGB, 7M, a 3-year Mass General Brigham EHR corpus with 7.15 million patients and 25.3 billion records spanning 28 modalities, including 158.7 million progress notes, 78 million diagnostic reports, and 1.16 million images. The architecture uses modality-specific encoders, Gatortron base for text, Titan, DynoBloom, and Conch 1, 5 for images, and learned embeddings for structured tokens projected into a 768 dimensional shared space and fused with a 1-2 layer 1-2 head transformer under 30% masked multimodal modeling. An ICD 1-0 mask token at inference yields a single virtual patient embedding summarizing the full timeline. The model's learned token space forms an atlas of medical concepts, clustering semantically related diagnoses, drugs, and unstructured findings without supervision, including cross-modal alignment between blood smear images, hematology reports, and lab abnormalities, on 322 held-out tasks from 1.4 million test patients. Linear Cox models on frozen. Apollo embeddings beat age. Sex baselines on 74 of 95 new onset tasks and 53 of 78 progression tasks, with particularly large gains in clinically relevant endpoints. 1. Year schizophrenia, ROC 0.9, 2 versus 0.65. 3. Year heart failure, 0.8, 8 versus 0.77. 3. Year type 2 diabetes, 0.85 versus 0.61. And 1. Year COVID, 1.9 mortality, 0.87 versus 0.82. On 30 cancer progression benchmarks, Apollo averaged 0.735 AUROC and outperformed a supervised transformer-trained end-to-end, a last progress note baseline, and an age-sex model. For chronic myeloid leukemia mortality, it improved by plus 0.31 AUROC over the note baseline. Retrieval over 61 cohorts showed strong semantic search. For example, top 5 accuracy, 0.734 for AFib on apixaban versus 0.245 for last note embeddings. Integrated gradients and leave one token out analyses recovered clinically coherent risk drivers, indicating the embeddings are both predictive and auditable rather than merely associative. Let's explore the second paper. Using large language models for embodied planning introduces systematic safety risks. The paper argues that LLM-based embodied planning has a distinct safety failure mode that cannot be detected by semantic refusal metrics. The authors introduced DESPITE, a deterministic benchmark of 12,279 safety-critical PDDL planning tasks spanning physical hazards and normative risks, with validation based on formal conditional effects rather than LLM judges or simulation. Across 23 models, they separate feasibility, safety precision, and a new metric, safety intention, which measures danger avoidance independent of executable planning. The key result is that near-perfect planning does not imply safe planning. Gemini 3 Pro preview fails feasibility on only 0.4% of the 1,044 hard split tasks, yet still emits dangerous plans on 28.7%. GPT-5 High reaches 99.5% feasibility and 81.4% safety precision, but even then, about 1 in 5 feasible plans remains unsafe. Scaling analysis over 18 open source models from 3B to 671B parameters shows that feasibility rises sharply with size, from 0.4% to 99.3%, while safety intention stays comparatively flat, from 37.6% to 56.9%. Log-linear slopes quantify this gap. Feasibility increases by 26.8 percentage points per order of magnitude, safety by 12, and safety intention by only 4.5, with slope ratios of 0.45 and 0.17 relative to feasibility. Safety rate is almost exactly multiplicative, with S is approximately equal to F times SI and a regression fit of R squared equals 0.99 across all 23 models, implying that larger open source models become safer mainly because they plan better, not because they better recognize danger. 3 proprietary reasoning models, GPT-5 High, Gemini 2, 5 Pro, and Gemini 3 Pro Preview, break the open source band with 81% safety intention. Task level analysis shows that longer plans mostly hurt feasibility, whereas higher safety effort and normative dangers disproportionately hurt safety awareness. Redundant actions also reduce safety intention, revealing direct sensitivity to noisy context. The main bottleneck is therefore safety awareness, especially for normative and collateral risk scenarios. Let's explore the third paper, Web Compass towards multimodal web coding evaluation for code language models. Web Compass introduces a unified 1,526 instance benchmark for multimodal web coding that spans 3 input modalities: text, image, and video, and 3 task families: generation, editing, and repair. Unlike prior benchmarks limited to static code correctness or single task coverage, it defines 7 task categories, including text, vision, and video-guided generation plus text, vision diagnostic, and visual diagnostic patching. The dataset is built through a multi-stage human-in-the-loop pipeline with deduplication via BGE, M3 embeddings, LLM-based labeling, GPT, 4.0 quality scoring, and manual curation, yielding 15 generation domains, 16 editing operation types, and 11 repair defect types, each stratified by easy, medium, hard difficulty. For evaluation, the paper replaces generic pass-at-case-style metrics with task-aware browser-level scoring. Editing and repair use checklist-guided LLM as a judge, while generation uses a novel agent as a judge that executes code in headless Chromium, interacts through model context protocol, synthesizes JavaScript tests, and scores executability, functional correctness, and visual quality. The judge itself is validated on 200 samples, where Claude Opus 4.5 reaches Pearson R equals 0.93, 0.96 against humans, and is selected as default. Across 10 models, closed source systems dominate: Claude, Opus 4.5, and Gemini 3 Pro. Preview lead with overall scores of 67.4 and 66.68, while the best open source model, Qwen3VL235BA22B Instruct, reaches 41.14, a gap of over 26 points. Visual quality is the most persistent bottleneck, with generation design quality and editing style conformance consistently below functional executability scores. On generation, Gemini 3 Pro Preview tops visual quality at 64.07. Repair shows high interaction integrity, but weak root cause targeting, indicating that models often preserve interactivity, yet fail to localize defects. Framework choice matters materially. Vanilla HTML generally outperforms React and Vue on generation and editing, while Vue is the hardest across tasks. Error analysis shows dominant failures are feature missing and resource, fail on generation, feature missing, incomplete on editing, and defect not addressed on repair, underscoring that Web Compass measures end-to-end web engineering rather than isolated code synthesis. That's a wrap on today's AI paper highlights. Thanks for watching.